Our next series is going to be about rational expressions. So let's talk about what these two words mean. Rational, you can interpret that to mean a fraction. So we're going to have some fractional expressions. And we know by now that an expression means there is no equal sign. So we're just going to be trying to simplify these, and you're going to be using a lot of the techniques that you used in the previous series about factoring those quadratics. But for right now, the first lesson is you're going to be asked, when is your expression undefined? Or you might be told to limit the domain of your expression. And this sounds a lot harder than it actually is. So let me just get a couple of examples and we'll work through those. Okay, here's our first rational expression. It is fractional form. Now, when they ask you, when is this undefined? Well, when is a fraction undefined? It's undefined when the denominator equals 0. So that's all they're asking you is, when is the denominator of this expression going to equal 0? Well, this expression has no variable in the denominator, and the denominator is 5, so it is never undefined. There are no limits on your domain, okay? So let's look at another. X plus 3 over x plus 5. Now remember, you've not been asked to solve this or simplify it or anything else. You've only been asked, when is this undefined, or to limit your domain. Well, when is your denominator going to equal 0? So what you do is you take your denominator, just like it is, and you set it equal to 0. Let's find out when this will happen. And we're going to solve it. Subtract 5 from each side. So x is equal to -5. So at x equal to -5, this rational expression is undefined. Or if you're asked to limit the domain, you could say x cannot be equal to -5. That would limit the domain. Where it is undefined is at x equals -5. So pay attention to what the question is asking you. Okay, let's look at one more example. Okay, as you can see, the complexity of your denominator is going to determine how hard this question is to answer. And these are still pretty simple, but you're going to get the idea. I'm still looking for the point at where the denominator is equal to 0. So I'm going to take my denominator, x squared minus 9, and I'm going to set it equal to 0, and then I'm going to solve it. Well, now you have a quadratic equation here to solve. So it's a little bit different. How do you solve a quadratic equation? That goes back to the previous series, my SQ series. So if you're lost right here, you need to back up and learn to factor. Okay, because that's how you solve a quadratic equation. So on this one, this is a difference of two squares, and it's going to factor into x plus 3, x minus 3. Then you're going to take each one and set it equal to 0. X plus 3 equals 0. X minus 3 equals 0. And we're going to solve. Subtract 3 from each side. So x is -3 here. Add 3 to each side. X is equal to 3. So this expression is undefined at x equal to -3 or 3. If you're asked to limit the domain, then you're going to put x cannot be equal to -3 or 3. Like I said, it just depends on what you're asked for. Okay, this was the first lesson in our rational expression series, so keep checking back and we'll get through this chapter as well. See you next time. Bye.